In English. So my name's Edmund Ronald, okay? I used to be an interviewer, I used to be a journalist. I'm used to being the dumbest person in the room, more or less, but today I'm also the oldest. It's a bit annoying. Anyway, I was a tech journalist. I did a few universities. I did telecom in Paris. I attended the computer lab at Cambridge University. Then I was a tech journalist, and I went back to school, École Polytechnique, to get my PhD in machine learning. So I know a little bit about this stuff, but not like you people, of course, because you're younger. However, I also published a bunch of papers. You can see the beginning of my bibliography on the right. So I actually have published papers, including in CACM, IEEE, computer, etc. I think I probably have published, because of my age, as much as most of the people in the room. I was also the founder of a conference called Artificial Evolution, which I think still exists, basically. So I was one of the founders and publication chair for one or two of the editions. So I know how this game works. So the point about this talk is that I'm going to explain to you what the rules of the game look like from the other side, okay? The other side of the mirror, the one you don't know about, which is how conferences are organized and how they are reviewed. And that allows you to understand the maze a little bit better and maybe to improve your papers, because I want to see some better papers. That's one of the reasons, okay? And now, the first thing you need to know when you're going to write a paper is you need to know that by the time you sit to write, you've already made too many decisions in a way. You've decided where you're going to publish it. That's really, 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 really important. We're going to come to that. You already have your results very often. Well, too bad. If you have the results, they're not going to change. That's a decision which goes into the paper. It's going to determine the publicability of the paper, at least hopefully so. We're going to see that's actually not true. So anyway, before you sit down to write this paper, have a look at what you actually have, because maybe it's better to go back to the actual computer and simply try and figure out if you need more stuff before you write. And above all, choose a better target, a better conference or journal to send it to. Now, let's try and understand how conferences work. I'm sorry, Frank and Igor. May I give a few of the secrets away of this game? Just a few, okay, not too many. The way this works is conferences have several tiers. At the bottom, of course, are you guys, well, most of you, the people who send in some stuff to be published, hopefully. We'll come to the reason for that later. Above that is something called a program committee, who are scientists, people who are really very solid in the field, who read the paper and at least set the review guidelines and determine what is a good paper or not. Excuse me, is there a problem there? Or no, okay. And very often the program committee, they set the guidelines, but then they farm out the actual reviewing to some poor grad students in their lab. That's not very good, actually, because the grad students sometimes have maturity issues, and also they are also fashion victims. It doesn't always help. That's my personal opinion. I think I'm allowed to have a personal opinion today, just today, okay? And then at the very top is an organizing committee, who are not necessarily scientifically oriented. They may be wanting to ensure the success of the conference. They don't want everybody to just be Google, Facebook, and I don't know, Palantir or whatever. They want some people from all over the world to come. They want the reputation of the conference to be fun and heavyweight and everything. So they actually go into this process, and after the papers are validated, they sometimes choose some of the papers to appear, not appear, etc., because you can't have, say, 20 papers from Google in the same conference and 0 from anybody else. I hope I make sense. Now, here is a review form, and you see that what's actually happening is that the topic is a very strong indicator. You have to be on topic, and this is an IEEE standard form. So the IEEE, you know, the Organization of Engineers, has a standard form. When you organize a conference, you very often choose it. And so the thing is, you have the results, very often you have the originality. In this case, there's not a lot of originality in here in this review form because it's IEEE, so IEEE doesn't care about originality. And you have a lot of points for presentation. Does it have the appropriate number of references? Is the abstract properly written, etc., etc.? Some of this you can be asked to rewrite, but not everything. Okay, so I have another 4 or 5 minutes to go. Am I right, Igor? I've got 5 minutes, five slides. Are we happy with that? Good. So this is the situation now. Let's try and understand what it actually looks like. At the very top of every conference are 10 or 20% of papers which are actually going to get published no matter what. The reason is they've been published by people who are very good, who have very good teams. So anything which comes out of those teams and is validated is first rate. Okay, lots of energy there. The organizers are, I'm not making this one up, dead frightened of these people. It used to be organizers were dead frightened of Caltech, MIT, Stanford, and I don't know, maybe Harvard Business Review, for all I know. So what these people send in always gets published in some way, except if they send in too many papers, then obviously there's a cutout. At the bottom, you have people who send stuff which is badly written, which is simply not appropriate for that forum very often. The results aren't there. It's just chucked out by a grad student who wants, who's hoping he'll get a paper in somewhere, etc. So these papers go into the trash bin immediately. They don't get anywhere. And in the middle, well, sorry folks, that's you. And as you'll see, if you'll chase up the last reference, which I'll give at the very end of this talk, NIPS ran an experiment some years ago, I think they might still be running it, where they have some of the papers re-reviewed by a different program committee, different set of reviewers, simply segregated, okay, it's a double-blind thing, and they noticed that actually, basically, getting papers from this middle bunch published is a lottery. There's no reproducibility about it, practically none. You can read it up. I've given one reference. Just read up NIPS experiment, type it into Google. Now, my recipe, the next 3 minutes is, how are you gonna actually get your paper published? Well, it's simple. You're gonna be a useful fish. Everyone is gonna like you. Why? You're going to have a nice paper, so the people who run the conference like you. It's nicely presented. The people who come to the conference are going to like you because you're going to tell them something. You won't tell them that the result exists. They know that already. You're going to tell them how it's usable. In other words, the reproducibility of something is in science also considered useful information, okay? That's the scientific method. An applications paper is essentially reproducing something, some method somebody else has used in your context, explaining the way you adapt the core algorithms to your domain. And very often, if say in signal processing, this means that somebody else seeing the type of signal getting processed and the pre-processing steps, say from an encephalogram, will be able to move to an electrocardiogram or something. And so it becomes a reusable recipe. How do I use deep learning to do this? What pre-processing steps are necessary? So you're going to be a pilot fish. And to do this, you have to write a really readable paper, okay? That's really important. So you have to spend time on it. You need time to write. Put that forward, but you can write the introduction long before you write the results. You can start writing the introduction when you start your PhD, basically. You can do it a long time before. You already know what you're going to working on. You know what the pre-processing steps are already. Put them in the paper. The reference is the same thing. You have to put a lot of references in. If I go back to this form, they actually ask whether the references are there, I think. That's very important. People want to be cited. Put the references in. And write the introduction, references, etc., and pre-processing well ahead of the deadline before you have your results. Explain your application, not the core algorithm. You're not the inventor of it. Google or somebody is, okay? Or I don't know, stochastic gradient descent is probably 30 years old. You're not going to explain it any better than anybody else. Or deep learning, the latest, the latest network, which is winning the competitions. If you're just cutting the head of that and using the body, you didn't invent it. So don't explain that. Explain your application and the pre-processing. That's important in an applications paper. How other people are going to do the same thing as you, okay? Not just that you did it, which we'll leave to the guys at the very top. Now, there's a rule of thirds. The third of the paper, in my opinion, now this is just my recipe, I'm giving it away to you. The rule of thirds is a third of the paper should be understandable by just anybody who opens the thing. Yeah, just about anybody who's a computer scientist or somebody in the applications field. A third should be understandable by people who either know about the applications or about machine learning. One helps you on the other side, the other helps you on the first side. We're talking now about an applications paper. We're actually talking about an applications paper. I don't have time to deal with every type of paper in the next 2 minutes, okay? And a third of the paper is really specialist, and that's where the core implementation details, discussions, etc., like the feature engineering stuff, which we talked about earlier goes, okay? Thank you. And my last words are, if you get accepted, do yourself a favor. That paper is going to stick around for a long time. Just polish it a little bit, improve what's bad, what needs to be a bit improved. If you get rejected, just have a look at the comments. There are some comments. And resubmit after you've dealt with them. And by the way, here's this talk about the NIPS experiment. You can see the overlap. Papers which get accepted by one don't get accepted by the other program committee, etc., and vice versa. It's a lottery, folks. Thank you very much for your time. And